All right, it's the top of the hour by my clock, so we're going to go ahead and get started. Thank you, everyone, for joining us today. Welcome. My name's Rebecca, and I work on the content team here at Gitlab. Now, before we get started, if you have not joined us for a webinar before, I'm just going to go over a couple of housekeeping points, just so you know what to expect. So feel free to ask questions throughout the presentation. If you look towards the bottom of the screen, you should see a Q&A box, which you can use to type in those questions as they come to you. We'll probably save questions for the end of the presentation, but go ahead and send them in as you think of them. You can also use the chat function to get us or get in touch with us if you're having any technical issues. If the sound drops out for you or anything, just send us a message there and we'll try to sort you out as soon as possible. Thank you very much for joining us today. Joining us as well is Matt Baldwin, the CEO of StackPointCloud. Matt worked with us and his team at StackPoint to integrate StackPoint and GitLab, enabling an end-to-end turnkey solution for Kubernetes, hopefully to help all of our users go even faster from idea to production. We'll start just by giving you some context about each of these tools and how you can now use them all together to simplify your tooling. And then Matt's going to go ahead and demo the turnkey piece so you can see it live in action. And then we'll finish up with your questions. But first, I'm just going to talk a little bit about what GitLab is. If you're new to us today, I imagine quite a few of you are familiar with us, so I'm not going to spend too much time on this. So you may know of us as a version control and code review tool. And that is definitely where GitLab started, but we've come a long way since then, and we have expanded our offering to bring issue tracking, social coding, CI/CD, and monitoring all under one UI, making us the only product that covers the entire software development lifecycle. So on this slide here, you can see some of the things that are built into Gitlab EE. In just a few minutes, you can deploy GitLab to a container scheduler, add CI/CD with automatically deployed review apps so you can check out changes as you make them. You can use chat apps and analyze your cycle time. So if you want to design, code, build, deploy, and monitor an application, you can do all of that straight from within GitLab. But of course, no software development tool is an island. So we do integrate with a lot of other tools and platforms so that teams can use GitLab in the way that works best with them. And that's one of the things that we're here to talk about today. So with that, I'm going to hand over to Matt to do his presentation.
Cool. Thanks, Rebecca. So my name is Matt Baldwin. I'm the CEO and founder of StackPointCloud. We are a Kubernetes cloud management platform company. So what that means is we allow users to quickly get up and running with Kubernetes clusters in the public cloud. We allow you to build and manage those clusters. We're production ready and we're iterating rapidly. We support multiple public cloud providers, so we are able to we're able to support things like multi-cloud, multi-region, multi-availability zones. We support things like auto-scaling any cloud against, so we could auto-scale Amazon as much as we can auto-scale Google or Azure. We're about choice, which is why we have been working with GitLab to enable the GitLab EE experience in our product, is we believe that users should be able to pick and choose what they want to use for their development environments. And so if you're a user that uses GitLab, you can get a turnkey Kubernetes cluster up and running with GitLab on top of that through our product. We also provide certified charts and integrations. Chart is a package format for Kubernetes. So if you think of, if you think of RPMs, so Red Hat package managers, charts are pretty much equivalent of that. So we provide a set of certified charts that can be installed into Kubernetes environments, as well as various third-party integrations. Additionally, we support things like ops tooling for those who need to operate these environments versus just develop on them. So we support things like upgrade, configure, reconfigure, as well as backup. We like to think of ourselves as a turnkey container strategy for any IT team out there. So why Kubernetes? I don't know how many people out there in the audience know about Kubernetes. Kubernetes is a container orchestration scheduling platform. What it allows you to do is deploy, scale, and operate containers across disparate set of resources and across multiple clouds. So operators are able to scale as their demand, as demand increases. They're able to add resources on the fly. They can remove them on the fly as needed. Developers can roll out new features seamlessly. They can perform green deployments. They can perform canaries, and all this is very much automated through the Kubernetes stack. So it's a powerful platform for running apps of any size and complexity. So you can have a very small microservice up to a very large microservice, and Kubernetes kind of fits that model across the board. It's extensible. So Kubernetes enables a very good cloud native ecosystem. It's highly portable. You can deploy your app to the Amazon and take that same app and then redeploy that app to Azure or Google. So you begin to get portability and extensibility there. On the extensibility side, you have things like third-party resources, which are now been renamed to custom resource definitions. So TPRs or CRDs are now basically third-party things that can be added into Kubernetes. And now, versus having everything have to be baked into the core upstream project. Lastly, Kubernetes self-heals. So if your application environment is running and you lose some of your services, Kubernetes knows to see that those services failed and to bring those services back online on another host. So if you have a node, say you have a 4-node cluster, one of your nodes fails, and you have, say, Nginx running on one of those nodes, Nginx will be rescheduled onto one of the other nodes and your service is back online. Through the self-healing and through the auto-scaling, Kubernetes also helps you reduce costs. So how you think about that is now, instead of over-purchasing your EC2 instances or whatever instances of whatever provider you have, you can now have Kubernetes use, so you can deploy a small cluster size, deploy your application to the cluster, and then the cluster can scale as resources are needed versus over-committing resources to your cluster. So this helps you reduce costs at the cloud providers. The multi-cloud aspect, where you can actually span multiple clouds, also allow you to separate components across different cloud providers. So if you have a better deal at Google for, say, ingress traffic, you can actually put workload there that has ingress traffic coming in and have a better deal, and then keep the rest of your workload at Amazon, as an example. Without Kubernetes, the entire distributed computing space would not be where it's at. Kubernetes is the cornerstone to distributed computing. It's what ensures high availability and self-healing and scale. Lastly, it has a very, very strong community. There's over 10,000 committers to the project. It is the most successful project on GitHub. And it is one of the most successful open source projects since the Linux operating system. A lot of people are looking at Kubernetes as the operating system of the internet. So instead of thinking about host systems, so things like Red Hat or Debian, Fedora, people are now thinking about how do you install things on top of Kubernetes? How do you write applications on top of Kubernetes? And with Gitlab EE, we saw that ISVs are beginning to retool their software to live on Kubernetes. So with this community and the scale of Kubernetes, we think this is going to be a very big thing and a very important thing for application deployment in the future. We see applications changing. We see applications moving into the microservices, and we see a solution like Kubernetes being needed to scale those and to manage those. So why are we working together? So one of GitLab's core requirements is that you must have a Kubernetes cluster up and running before you can even begin to use it. So for us, that's the last mile and a painful one for many users out there. So I don't know how many people have attempted to stand up and manage a Kubernetes environment, but it's a complex task. Kelsey Hightower has a great set of content out there, and we could pass the GitHub link into our chat here. But we put together a lot of documentation. It's called Kubernetes the Hard Way. It's a thorough set of documentation that takes you through every minute detail that you would have to worry about when you're standing up a Kubernetes environment. Things like how do you stand it up so that you can actually upgrade the Kubernetes cluster in the future without having to actually tear it down and then rebuild it. How do you manage etcd, which is a requirement for Kubernetes to even operate? How do you ensure that etcd self-heals? How do you ensure all these things? How do you ensure auto-scaling is working correctly? These are all aspects of the problem that you would have to actually solve if you were to go and stand this all up on your own. And so you'd have to do all that prior to actually deploying GitLab EE into the environment. So what we've done is we've worked together to create a integration where we created a turnkey solution. So now you have a fully managed GitLab EE environment on top of Kubernetes through us. We also have a variety of operator tooling to help manage that GitLab environment. You can back up your GitLab EE state, cluster state, and easily recover that state. You can actually take that state and restore it, basically build out of the Kubernetes cluster out of another provider and restore that state and do an easy migration that way. We also allow you to configure and reconfigure the environment and scale the GitLab environment, along with upgrade it all through the interface. Additionally, what we've done with GitLab is ensured that the GitLab environment itself is self-heals and that it is redundant. We turn on auto scaling so that if you're seeing load, if you're doing something inside the GitLab EE environment that is causing load, things will start to scale and you'll be able to compensate for that load, and then things will, load will diminish, resources will diminish. We also allow you to separate if you run multiple GitLab environments for whatever reason. We actually allow you to separate those in test, staging, and production. We have security tools that we can bundle with GitLab, so you can actually secure it with Twistlock, which is a container security product. You can use Calico if you want to introduce network policy security. We turn on logging, so we actually log your GitLab clusters. All of the events are getting logged into Elasticsearch via FluentD. We also deploy a monitoring dashboard for you. So if you want to see what's going on in your environment, you can use Prometheus, which is an open source project that runs inside of Kubernetes. But by default, you don't get any dashboards. So what we've done is we've pre-configured all those dashboards for you. So when you add that, that gets added in the environment, then you can just go to Prometheus and see what's going on, So how we look at it is it's pre-configured and ready to go. And then I'm going to head into the demo. So we support 4 different social authentication providers to log into the application. We support GitHub, Google Apps, Twitter, and DigitalOcean. So the unique thing with the DigitalOcean auth is if you're actually a DigitalOcean customer, you can use your DO credentials, authenticate into the application, and then you are not required to provide your API tokens. We can immediately begin to talk to your DigitalOcean environment. So let me just log in with my GitHub account. So right now I have 2 clusters already stood up and running. This is going to be kind of like a Martha Stewart style where I've already baked the cake, and I want to show you how to bake the cake. It does take about 10 to 15 minutes for a cluster to stand up. So let me just kind of show you how that works. So to build a cluster with GitLab EE on there, you would just tap Add a Cluster. Choose your provider. In this case, I'm going to choose Amazon. We do make some we do make some decisions for you based upon our previous experience with other solutions and with kind of operating Kubernetes in a production environment. So we choose T2 large instances, and you'll also notice that we default to a single master, and we only have 2 worker nodes. This is just to provide a very, very small size base cluster. After the build is done, you're actually able to go and add extra masters, or extra nodes if you wish. You can actually add multiple workers here if you wanted to, but our decision was mainly to save costs on the customer side. We allow you to change things, and we make some default settings. So we pull the region out of your Amazon account. So whatever default region you're set to on Amazon, we'll set that to your default region. We allow you to override it through here, but by default we try to make a lot of decisions on the user's behalf, so that and we try to make sane, good defaults basically. That way, there's not a lot of configuration before you actually can get working. We allow you to choose a zone, so you can distribute your cluster across into any of the zones. Here in a second, I'll show you how to actually do where you can place nodes in one zone and keep nodes in another zone, as well as do things like node pooling. If you don't have a VPC, we'll create one for you, or you can choose a VPC and have us build the cluster in that VPC. Same goes for subnets. If you have one, we're happy to use it. If you don't, we'll go ahead and create it. We also have a concept of workspaces. So, and I'll get into this a little later, but a workspace is basically, think of it as a bucket that your Kubernetes cluster is going to live in, and that you can grant access to that bucket to users and teams. We also provide a default SSH key that you can download, one-time download through us. When your cluster's built, that'll give you shell access to your nodes. Optionally, you can provide your own SSH key, and then you'd have shell access to your nodes. Once I talk about the workspaces, I'll explain how an ops team can ensure that their SSH key gets placed on a cluster. So the next step before we build a cluster is to kind of configure our cluster and finalize this configuration. So this is what would by default be built out. Right now, we don't have Gitlab EE selected. So if I wanted to select Gitlab, I would just go into the solutions view. So I'll do that did that a little too fast. So I just hit solutions down here. As you can see, we provide a variety of things. Today, we're just going to do GitLab. But say I wanted to add in Twistlock, I can just drop Twistlock right there. The only issue is things like Sysdig, things like Twistlock are licensed products, and they're licensed via a Kubernetes secret. So we're actually able to add that license into the build flow. You would have to actually provide the Twistlock license or the Sysdig license prior to us being able to stand it up. So that's just one of the issues that you would have to overcome, is to grab a license from them. But if you wanted to have, say, Prometheus, you'd be able to just grab Prometheus, drop it in there. And like I said earlier, if you did choose Prometheus, you'd actually have dashboards that would show your running environment. We do support various distributions. So we support CoreOS's Container Linux, and we support all the channels, so stable, alpha, beta. We also support Ubuntu. And a lot of people do ask us why we don't support like basically every distribution. And what we're finding in our experience with people beginning to adopt Kubernetes and run on top of Kubernetes is that the host operating system is not as important as it used to be. And we're seeing people begin to save costs by now that you're instead of worrying about host management, you're worrying about app management inside of Kubernetes. Worrying about the host is less of a focus. So we're seeing users actually gut their Red Hat environments and replace that with things like Container Linux. And that's already a cost savings on their side. So that's something that Kubernetes introduces, is you can actually start to do that. We do support etcd. Etcd is a requirement of Kubernetes. We support a variety of setups for etcd. So we can do etcd side saddle cluster, which is basically a black box Kubernetes cluster running a dedicated set of etcd instances, 3 nodes. That's usually a cluster geared towards a Kubernetes cluster that's going to equate to a large set of nodes, so like 50 to 100 nodes, or a large amount of workload going on. Most users are not going to need that. So for most users, we do etcd in cluster. Etcd is deployed as a self-healing component. So there's multiple etcd instances running. Any of those instances can die and you're still up and going. We do the same with master. All the master components run inside of Kubernetes. And if the master dies, it just gets rescheduled. Kubernetes just reschedules it to another node. I'll show you how we do that here in a second. By default, we also ship the Kubernetes clusters with AJ Proxy. So AJ Proxy we've rewritten it as a native ingress controller inside of Kubernetes. So it's an Nginx replacement, and that comes with every single cluster. You don't need to have it. You can just remove it. We also ship Helm, which is if you recall me mentioning charts earlier in the webinar. Helm is the command line utility that is used to install charts into a Kubernetes environment. And so it has a server-side component called Tiller. And so what we do is we actually add Helm Tiller into your environment, so it's pre-ready to go. So you don't have to do any of that setup if you want to add additional apps into the environment that are not available through our product. The last thing you do is you just click submit, and then you'd get an error because I'm out of limit. I've hit my provider limits on Amazon, so we will just exit out of that. That's actually one of the interesting things we ran into when we started doing a lot of scaling with Kubernetes, is that Amazon does introduce a lot of limits, and you can hit those really fast with Kubernetes if you're trying to scale into large nodes. So I have two clusters running right now. I have one at DigitalOcean. I have one at Amazon. I can drill into my cluster details by just tapping on it. As you can see, I have my two workers and one master. Now you're like, that's not highly available. So your master, you have a single master that goes down. Now Kubernetes can't schedule pods anymore into your environment. And it's very important to understand that if your master components do go down, so the master components are basically everything that Kubernetes relies on to schedule pods, manage the environment, do things like that. So like there's the scheduler, scheduler controllers, the API, the proxy. If all those components were to die, your operating environment actually would still stay online until one of those pods were to go offline for whatever reason. At that point, there would be nothing there to tell the system to bring a pod back online. So that's the only risk that you have if the masters go down. Obviously, you don't want them to go down. But say you do want high availability there. We allow you to add multiple masters. So if I wanted to add 5 more masters into my environment, I can do so. If I wanted to drop those masters across, if I want to drop those all into availability zone B, I can go ahead and do that. I can also, through the same interface, you'll notice here I have node pools, what we call a pool. If you're familiar with GKE, Google introduced a concept called node pooling. And what that is you can have, say, 10 nodes in a cluster. 4 of those nodes are large, 6 of those nodes are small. A node pool can say, so that 4 large nodes are part of node pool 1, the 6 are part of node pool 2, and then you're able to actually taint, or you can apply taints or tolerances to deployments inside of the environment, and then you can schedule those specifically to the large nodes, and then you can also auto scale just that single node pool versus auto scaling the entire environment. We do support. So what we did is we took that GKE node pool concept and then we applied it across all of the cloud providers that we support. Along with GKE. So we do have GKE in our app, and that is in the app to enable support of installing various solutions on top of it, along with being able to federate and do multi-cloud with GKE. So in this instance, I can go, I want to create a new node pool. If I wanted 3 nodes, and if I wanted these to be, M3 2x large, I can go ahead and do so. And what this would do is go and stand up 3 more nodes at that size, and they would all be part of the same cluster. So this would allow you to actually separate any of your GitLab components into instance sizes or nodes that match the kind of the resource needs of that particular service or component in GitLab. We don't do that by default yet, where we intelligently say, hey, we're going to take this component, add it here, or take this component, add it there. We also allow you to easily get to your GitLab console from here. So if you wanted to, you could just hit this link and then we send you over there. We provide a signed certificate that's valid certificate for your URL. You'll notice that we also give you a fully qualified domain name, so you don't have to worry about anything like that. So any of the apps that you install will have a dashboard link if there is a dashboard. So if you had Prometheus in there, you'd be able to just come in here and tap the Prometheus link and drive right into Prometheus, all via a fully qualified domain name, all via a certificate that we've issued from Let's Encrypt. You can see your etcd, basically that your etcd cluster is hosted here on your cluster nodes. We don't have much more in this page yet, but we're going to be adding a few things like restore etcd. We allow you to back up your environment. So if I wanted to back up, I would just enable Kubernetes state backup, and then I'd be able to choose between Google Cloud Storage or AWS. Again, we default to the region that you are tied to at Amazon. In this case, I am on US West Oregon. And then you can also set your frequency. As soon as you save this, we begin to create a backup immediately. And then from then on out, we start to take a weekly backup once a week. You can also view the event log of what's going on in the environment. So as we do things, we record events in here and kind of let you know what's happening. If you hit an error, this is where the event would be. The event would actually tell you what the error is. So like you saw, I hit that maximum, number of instances built out problem on Amazon. So resource limit, that would have been surfaced also inside the event log if you wanted to go dig in and see what happened. We do support right now 1.6.4, which is a little older version of Kubernetes. We are shipping 1.7.0 here soon, but we're testing through it right now just to make sure it looks solid. We try to stay a couple versions. We try to always have the latest version within a week or so of it dropping, all depending on how it tests out with all the other solutions. So we do a lot of integration testing. So with Gitlab EE, we're right now validating Gitlab EE could be deployed and run successfully on top of the latest version of Kubernetes before we actually support it in the app. So as soon as it's supported in our app, you know that GitLab and everything else will work on top of that, and all the components will work together. We allow you to download your kubeconfig file. So Kubernetes can be managed through the command line using a tool called kubectl. kubectl requires a config file that has your target cluster in there, has your credentials, and a variety of other, and that's basically it. We pre-compile that kubeconfig file for you and allow you to just immediately download it. So now I would just be able to go to my command line. As soon as I export that config, I'm good to go. The Kubernetes project also ships with a dashboard, and we allow you to reach that dashboard through a SSL tunnel in our app. So right now, what I'm doing is I'm actually hitting the dashboard running inside the cluster at Amazon. And from here, I'm able to see basically all my containers running. So all my pods running. I can see my GitLab EE Postgres SQL container pod. I can dig into, services if I wanted to. So I can see Heapster, I can see GitLab, everything. And this is something that we ship by default. You get some basic metrics here for CPU memory usage. If you dig in, you can start to get metrics a little bit more granular off of these things. If you wanted to, you can grab. If you wanted to see what's going on in a particular pod, you can actually look at the logs as they're going. So pretty cool. Now let me just go back to here. So if we had 1.7 Kubernetes available, you would actually be able to hit that link, hit that menu, and be able to do an upgrade. And we would do an in-place upgrade of your Kubernetes environment without taking anything offline. So you basically stay online 100% of the time while we perform the upgrade. Upgrades take about 5 minutes to complete. So pretty easy. We also support federation. So inside of Kubernetes, there's a concept called federation, but outside of Kubernetes, a lot of people understand federation to be federated authentication. When in context of Kubernetes, what we're talking about is federating two clusters together so that they can actually share and split workload. You can migrate workloads between them, a variety of things like that. So we do support that. We allow you to choose what your federation host is going to be. So say I want to now take my GitLab EE cluster that is running right now, and I want to choose to federate it. So I'm going to go ahead and federate it as Borge. So now if you wanted to access any of your resources on that federated cluster, regardless of where those resources are at. So I'm going to choose AWS and click submit. So now here, I'm choosing to bring a DigitalOcean cluster into my federation control plane. And what this allows me to do is if I want to hit borge.com, I can have 50% of my resources running on Amazon and 50% of my resources running on DigitalOcean, and my global DNS will route me to the correct one. So Borge will load balance me to either of the two. You can also get a little bit more advanced with Google's DNS if you wanted to. So that's federation. I'm not gonna create a federation right now, but what you would be able to do once it's stood up is you can actually add in more clusters into the federation. So if you had an Azure cluster and a Google cluster, you can actually bring those in and begin a split workload up that way. You can also disband a cluster, so destroy the cluster. Disbanding a cluster does not destroy the clusters. It just says the cluster control plane's not there anymore. So don't just basically break the trust between the two clusters. You can also, evict a single cluster out of the federation, a variety of things. Lastly, we support a concept of organizations, and in there we have workspaces. So you recall I mentioned workspaces earlier. So a workspace allows you to, kind of set up things like test, staging, production. And then you can actually scope your things like provider credentials. So you'll see that I have DigitalOcean, and it's right now organization-wide access, and my Amazon tokens are organization-wide access. I can actually add credentials and choose to scope those credentials to the provider of choice. Say I only want my development team to be able to build Kubernetes clusters or build Gitlab EE clusters at DigitalOcean. I can restrict that. I can say, here are the DigitalOcean tokens. Here's the here's the here's the SSH keys that are tied to that, so I can ensure that my ops teams always have access to that development cluster. The development guys can't override the ops guys' SSH keys. So we provide for a lot of that. And that's basically it. So any questions? Over to you, Rebecca, I guess.
Okay, thanks, Matt. Yeah, we did have some questions coming through. Someone asked, the term public cloud was mentioned, and I see public IP addresses for attached to Kubernetes nodes. Is it possible to configure this in a way that is completely internal to the VPC, that is not publicly accessible?
So right now we are working on, so you're talking about basically having a bastion host that you would bounce through and then jump into your private Kubernetes cluster, I would imagine. We do have plans to support that right now, but we don't support that at the moment.
Okay, thanks, Matt. Any other questions? Feel free to submit them now. Otherwise, of course, you are welcome to email webcasts@gitlab.com, so we can always get back to you after the fact. If you're watching us on demand, feel free to submit questions that way as well. So we will send the recording to you afterwards, so that you can review it at your leisure. And you can always find us on social to ask questions there as well. If you want to give GitLab Enterprise Edition a go, you can sign up for a free trial at the address below. There's no credit card required or anything. It's totally risk-free. So give it a shot now. Yeah, otherwise, thanks very much, Matt, for the presentation. And thank you all for joining us. We'll see you next time. Bye now.